guys, how's everything? Hopefully this has been helping. I saw the results already of some people are submitting it. It looks like the scores have gone up, which I'm happy to see. Others, if it's not helping, just feel free to go back and actually review it again. Take some notes if you have to. Don't ever think about not going back and rewatching something if it helps you out, because they're there to help. So the other day, what we worked on was circumference of a circle, knowing that whenever you have a circle, you know that everything that goes around the circle is circumference, literally called circumference. And circumference is how much goes around a circle. And then you have what's on the inside called area. And area, again, is always what's on the inside. Circumference is always what's on the outside. And you have the formulas too, which if you ever need to, I created an option on Pearson Realize that says geometry formulas. Always feel free to open that up, use it for any lessons, use all those formulas for quizzes, tests. I'll always be updating that on the regular. So we have a circle, we have the area, and again, just basics that we learned too with a circle, where a circle is always any figure that has no sides, and it's always determined by the center. And quick review, because again, I saw some people were making mistakes. Whenever you have a segment from the center to the side of the circle, if that, let's say, is 4 inches, we know that the radius is 4 inches, right? And if the radius is 4 inches, we know that the diameter, which goes from one side to the other through the center, if the radius is 4, you know that the diameter is going to be 8. Because again, the diameter is always double the radius. So if the radius is 4, you know that the diameter is 8. Just be careful with that, guys. And we also learned not only how to figure out area and circumference of a circle, we also figured out how to figure out the arc length of a part of a circle. So instead of having an entire circle, we have a part of a circle called the sector. And again, the sector is just a piece of the circle, right? Where you have a sector. Again, I'll review. You have a sector. If you wanted to figure out how long the arc is going to be, so if we were to call that AC, you would refer that as AC, right? And since it's on the outside, it applies to circumference. And since it's an arc, you would put an arc there. And whenever you see the letter M, it just refers to measure, the word measure. So what we did yesterday was figuring out how long the arc length is going to be for a sector. That was dealing with the outside of the sector. What we're going to do today is we're actually going to work with figuring out the inside of the sector. And again, since we're talking about the inside, you know that that's always referring to area. So yesterday's formula, whenever we figured it out, was a long formula for finding the arc length. Today we're going to work with area of a sector. And what area of a sector is, again, is you have a piece of a circle. Okay? We have a sector right there, right? We have a radius, right? So let's just call that R. And then we have the measure of the central angle, which again, central angle, it's just an angle that touches the center of the circle. And what we used yesterday, we used a Greek letter called theta. And it just represents the measure of the angle, right? So whenever you're trying to figure out the area of a sector, trying to figure out how much space is actually inside of the sector, it looks a little bit like yesterday's formula, but there's going to be one major difference. So the first part is, if you're trying to find the area of a sector, we'll write AS. Literally stands for area of a sector. And it's exactly what we saw yesterday to most extent. It's going to be a proportion where it represents a part of the whole circle compared to the whole circle. And so when we look at it this way, and I'll explain it. The theta, since it represents the angle, it represents a part of the whole circle. So since this is a piece, we know that that's a piece. So think of it this way. That's a part of the area. This is going to be the whole area. That's a part of the angle. This is going to be the whole angle. And since we're talking about a circle, you know that a circle automatically adds up to 360 degrees, right? So you have a part of the angle out of the whole circle, 360. We have a part of the area of the circle over the whole area. And since we're talking about the entire area of a circle, you would use the formula for area of a circle, which is pi r squared. And that's where all this is coming from. This is literally area of the whole circle. This is area of part of a circle. This is the entire circle, 360. This is going to be part of the circle, whatever that angle is going to be. And again, it looks a little bit like yesterday's formula, and it should. The only difference is yesterday we didn't use pi r squared. Yesterday we used 2 pi r because that's circumference. Circumference is dealing with the outside. And since we're dealing with just the inside now, you're going to use the formula for area. Never going to change. So if anybody ever asks you to find the area of a sector, you're always going to use this formula. And again, the 2 things you always need, you need to know the radius of the sector, and you need to know how big the angle of that sector is going to be, always. Without that, it's impossible to figure out the area of the sector. But now, again, looks complicated. If you understood yesterday's lesson on area of arc length, my apologies, you're going to actually understand how to do this. If you don't, it's no worries, because again, we're actually going to figure this out. We'll do 2 examples together just so you guys can actually see it, see how it's applied. And then from this, hopefully you guys can then go and do well on the examples. Again, always feel free to reach out to me if you have any issues whatsoever. So again, let's say that we have a sector, right? We have a sector right here. And what we want to do today is we want to figure out the area of that sector. So again, let's use easy numbers. Let's say that that's 100 degrees, that angle. And let's say that the radius here is 3 meters. And since I want to find the area of the sector, I would use the formula for area of a sector. It would be AS over pi r squared equals theta over 360. And now again, let's just substitute the parts that we know. Since we're trying to find the area of the sector, we're going to leave it as that. So it's going to be AS over, now let's substitute what we know. It's pi r squared, so what we need to substitute here is the radius, right? And since we're dealing with this sector, we see that the radius is 3, right? So since the radius is 3, we're going to substitute it there. So it would be pi, radius is 3 squared, right? And all we did again, we just substituted the radius for 3. So we wrote pi 3 squared. Now for the other part, whenever we're dealing with theta, again, theta is just how big the angle of the sector is. And in this case, since the angle is 100 degrees, we're going to write 100 degrees right there. And then over 360. Again, that never changes just because the 360 represents the whole circle. The 100 represents a part of the circle. And think of it this way. This represents the whole area. This represents a part of the area. So now once we have that, and let me start getting rid of some things just so it doesn't confuse you. We have that, all right? So now once you're looking at this, and all this was again was just using the formula for area of a sector, it's just simplifying. So before we do anything else, let's just slowly simplify this part over here. So we have pi times 3 squared. And whenever you're dealing with order of operations, you always got to remember, you always have to do exponents before you do pi. So first thing we want to do is 3 squared. And just be careful, because again, 3 squared, some people are going to do 3 times 2 and say 6, but it's not. Because 3 squared literally means 3 times 3. So we know that that's going to give us 9, right? So 3 times 3 is 9. We have pi right there, and we can write it as such. And then nothing else has changed. You know that AS is still there, area of a sector, right? We know that the 100 is still the same because we didn't use it. And we know that the 360 is still the same because we didn't use it. So the only thing that changed so far is we did 3 squared, which gave us 9. And again, we do that first because exponents before multiplication. And once we have this, now it's easy to actually simplify it some more. Because from here, we can actually choose to rewrite this. We have AS, which we're not changing. And now we can do 9 times pi. Always remember, guys, some of you may want to use pi and keep it as 3.14. So what we want to do is, in essence, write, instead of writing pi, some people may write 3.14. And what we want to do now is multiply those two numbers. 9 times 3.14, which is going to give us 9 times 3.14 gives us 28.26. 28.26, and nothing else changes. The 100 is still the same, and the 360 degrees is still the same. So far we have that. And now, since we're working with a proportion, you know that the way that you always solve a proportion is by cross multiplying. So we're gonna end up doing AS times 360, and we're gonna do 100 times 28.26. And again, let me get rid of this over here to not confuse you guys so much. So once we're here, we know that 360 times AS is gonna give us 360 AS. We did 360 times AS. Next, we're gonna do 28.26 times 100, which is gonna give us 2,826. Okay, this literally just came from multiplying the 28 times the 100. 360 AS came from multiplying 360 times AS. And since it's a proportion, you have an equal sign. Now the last thing we gotta do to solve for area of a sector is we wanna get AS by itself. We wanna isolate AS, which means we have to get rid of 360 degrees. When you get rid of 360 degrees is always think. Whenever you're trying to isolate a variable, you gotta do the opposite. And whenever you have the number next to the variable, it always represents multiplication. And the opposite of multiplying is dividing. So divide that by 360, divide this by 360. We know that the 360s cancel out. And once you divide them, it gives you 2,826 divided by 360 gives you 7.85. And we can't forget, it's gonna be meters squared. And the reason that it's squared again is whenever you're dealing with area, area is always squared. Always. Again, that's area of a sector. It's just using the formula, guys. And again, we're gonna do another example to see if it can help you out or not. Hopefully you're starting to understand how to do this. If not, we'll do another one. But just remember, the 7.85 meters squared means how much space is actually in this sector. Let's try another one now. And again, if you ever need the formulas, they're all under that page that says Geometry Formulas under Pearson. So let's try another one. Let's use a different color. Let's say that now we have this sector here. And I'll try to draw it as small as possible just so I leave myself more space to write with. Two things that we need if we want to find the area of this sector. We're going to need a radius and we're going to need a measure of that angle. So let's call that angle 35 degrees in measurement, right? And we'll say that the radius here, let's call it 4 feet. And what I want to do again is find the area of the sector. I want to figure out how much space is actually in that sector. So to figure out area of the sector, use the formula again. AS over pi r squared equals theta over 360. And again, it's just substituting everything that we know. So the first thing we know that the radius is going to be 4. So even before that, let's write the stuff that we don't need to touch. You have the area of the sector, which doesn't change. You know that the radius is 4. So we're going to write pi 4 squared, right? And nothing else is going to change. We know that theta is the 35, which stays the same. And we know that 360, nothing changes. It's just the entire circle. So what we did again, it's exactly what we did before. We're trying to find the area of the sector. You know that the radius is 4. Nothing else changes. Pi is still there, square is still there. We know that the angle measure for the central angle is 35 degrees. And we know that the 360 represents an entire circle. Once we get to this point, now it's just cross multiplying. But before we cross multiply, it's good to simplify. And what we're going to try to simplify is this again. So nothing else changes. We have that AS is still there. We know that 35 degrees is still there. We know that 360 degrees is still there. And now what we want to do is we want to multiply this out. So before we do multiplication, we want to do 4 squared, which again means 4 times 4. So 4 times 4 is 16. And then I'm going to write pi there. So 16 was 4 times 4. The pi came down, which ended up giving us 16 pi. And we're not done yet because again, we can end up multiplying that out to give us a decimal to make our life a lot easier, which I'll end up doing over there now. So once we do all of this, we're left with AS. Let's do it here. AS over, let me move this stuff out of the way, just so it doesn't get in the way. We have AS, we have 35, we have 360, and now let's do 16 times pi, which again, some people when they say the 16 times pi, they're gonna see 16 times 3.14, same thing. It's always the exact same thing whenever you're looking at it. So now if we do 16 times 3.14, 16 times 3.14 is going to give us 50.24, right? 50.24. And again, literally all we got that from was doing 16 times 3.14, which is always the estimate for pi. So let me get this out of here just to not confuse you guys. We have this. Started off with the formula, substituted the radius, everything else stayed the same, substituted the central angle, did 4 times 4, which gave us 16, did 16 times pi, which gave us 50.24. And once you get to this point now, it's just cross multiplying like you guys have done so many times. So you're gonna end up doing 360 times AS, which gives us 360 AS. We're going to end up now doing 35 times 50.24. 35 times 50.24. Sorry, put the wrong number in. 35 times 50.24, which gives us 1758.4. 1758.4. And I'm going to rewrite this over just so it's easier for you guys to see. And we know it's equal because equal sign is there. So what we want to do is we want to solve for AS. And again, let me rewrite this over just so it's easier for you guys to see. We had all that there. And I'm just going to rewrite this again. So it's going to be 360 AS, which is equal to 1,784.58. I'm sorry, guys. 1,758.4. So we have that. All we did, just brought this up, just so you can see it better. And now if you want to solve for AS, you have to divide. Divide by 360, because again, whenever you have 360 next to AS, whenever you have a number next to any term, it's always multiplication. The opposite of multiplication is division. Divide this by 360, divide this by 360, 360s cancel out, and we're left with AS, area of a sector, is going to end up being, let's do this now, 1,758.4 divided by 360 gives us 4.88 feet squared. And again, it's squared just because whenever you're dealing with area, area is always squared. And again, just remember what the answer means. It means that inside of this space, inside of that sector, there's 4.88 feet squared. Again, always remember, guys, circumference is how much is on the outside of the circle. Area is how much is inside of the circle. If we're talking about arc length, we're talking about how much space is on the outside of a piece. And if we're talking about the area of a sector, we're talking about how much space is inside of a piece of a circle. All these formulas, again, they're all in the formula sheet for the geometry formulas under Pearson. Feel free to access them. Feel free to rewind this. Any questions, guys, feel free to let me know. Good luck.